Hello everyone, I'm Living Zhen. I will be presenting our approach to obtaining a personalized generative file with explicit control over a set of attributes. Unconditional GAN-based image synthesis approaches, in particular StyleGAN, can generate high-resolution results that are distinguishable from real images. Built on the success of StyleGAN, a large number of methods use it as a prior for image manipulation, such as super resolution and semantic editing. However, as shown here, the super resolved and edited images do not resemble Michelle Obama, as these approaches use generic priors. To solve this issue, Nizam and colleagues propose MyStyle to personalize a pre-trained generator given a few images of an individual. Specifically, MyStyle first projects the images into the latent space of the generator, producing a set of anchors. It then tunes the generator through minimizing the loss between the generated images and the corresponding input images to obtain a personalized latent subspace. With the personalized prior, MyStyle is able to produce results that preserve the identity. For example, as shown here, the super resolved and edited images resemble Michelle Obama. Unfortunately, the edited results produced by MyStyle are not fully distinguished. For example, here removing the smile results in changing the yaw angle. To understand the source of the problem, let's see how MyStyle performs the edits. MyStyle first inverts the image into the subspace, and then moves the latent code along smile direction provided by interface scan. However, if the user is edits, the latent code quickly falls outside, producing results with altered identity. To address this issue, MyStyle personalizes the editing directions by projecting them into the subspace. However, the projected directions are no longer able to provide distinct edits. As seen, changing the smile also alters the yaw angle in this case. Note that this is not unique to the directions from interface scan. This problem exists when using any controllable GAN-based approach within the personalized subspace. In addition to this issue, MyStyle didn't demonstrate precise control over the attributes of image synthesis. For example, to synthesize an image with a smile, one should repeatedly sample the subspace to reach the desired image by chance. Our goal is to address these problems by providing full control over a set of predefined attributes of the generated images. Specifically, we would like the personalized subspace to be organized along a set of known attribute directions, such as smile and yaw, to be able to sample images with desired attributes, and perform distinct editing, as shown here. Our key observation is that we can organize the latent space by only rearranging the anchors. This is because StyleGAN's output changes smoothly, and thus, as an anchor moves, its neighborhood will be dragged. Based on this observation, we personalize a generative prior by proposing an anchor loss, which is optimized in combination with the reconstruction loss. Our optimization both tunes the generator and organizes the latent space. Before explaining our anchor loss, I'm going to discuss the properties of an ideal latent space. Firstly, its attributes should change along a known direction. This is ensured we can perform semantic editing and changing a particular attribute by simply modifying a latent code along that attribute direction. Secondly, all the latent codes with the same attributes should project to the same value on that attribute direction. This allows us to directly sample an image with a certain set of attributes. Thirdly, the directions for different attributes should be orthogonal. This ensures changing one will not result in modifying the other attribute. In our approach, the anchor loss is responsible for organizing the latent space. Now, let's see how we formulate our anchor loss to satisfy the properties of the ideal latent space. I'm going to explain our loss for the smile attribute. Let's see, this is the direction of smile, ds, and these are the anchors of 4 smile faces. Our loss minimizes the distance between the projected anchors and C, where C is the average of the projected anchors. Minimizing this loss forces these anchors to project to the average. We optimize this loss on other values of these attributes. For example, anchors without smile. As well as other attributes like yaw with different values, such as left-facing, frontal, and right-facing. We've shown that our anchor loss enforces latent with similar attributes project to the same value, and also ensures that each attribute is changed along its specific direction. To satisfy the third property, we apply principal component analysis to all the anchors to obtain orthogonal attribute directions. Note that we calculate the PCA at each iteration of optimization, so as the anchors move, the directions are updated as well. Minimizing our anchor loss along with the reconstruction loss, the controllable personalization can be achieved by tuning the generator and organizing the latent space. Next, I will show a subset of our results in image synthesis and editing. Let's first look at the image synthesis where we compare against the MyStyle. We propose a simple strategy for MyStyle to perform controlled sampling in the personalized subspace. Please refer to the paper for details. Let's first see image synthesis with a fixed expression. While the desired expression is smiling, MyStyle produces images with different expressions, including results without a smile. In contrast, our method produces consistent results. Here we show results with fixed yaw. Though left-facing images are desired, MyStyle generates images with very angle, even front face. Let's take a look at the results with fixed edge. MyStyle exhibits diverse edges. In contrast, our method generates images with a consistent teenager appearance. Next, we show results on image editing. We first show comparison against MyStyle for expression editing. While removing the smile, MyStyle produces results with altered identity. Next, let's see a comparison for yaw angle editing. MyStyle changes the expression while modifying the yaw angle. In comparison, our edits are better disentangled. Lastly, we show a comparison for edge editing. Unlike our method, MyStyle produces results that do not resemble teenager Leonardo DiCaprio. Next, I'm going to conclude the talk. We present an approach to obtain a controllable personalized generative prior. We propose a loss that organizes the latent space according to the attributes. We demonstrate the controllability of our approach in image synthesis and editing. Thank you.